So question 26 in the review, the ages and years and heights and inches of all pitchers for a baseball team are listed. Find the coefficient of variation for each of the two data sets and then compare the results. So that's how we have two formulas for the coefficient of variation, one involving population and one involving sample. Remember, since we're involving, sigma and S stand for standard deviation, remember the formulas are different for standard deviation because when you do a sample, you have to divide by n minus 1. So this the standard deviation of a sample is actually a little bit bigger than the standard deviation for a population. So since we have this little icon, I'm going to try to export this data out to Excel. So notice how we have to divide the standard deviation by the mean. And then we have to change it into a percent, if you will, by moving the decimal, two places to the right. So I'm going to take it out to Excel. Let's see what we got here. So we have our heights and our ages. So remember, to do the coefficient of variation, we need to know the standard deviation. So come over here and type in standard deviation, and then we also need to know the mean. So if I hit equals, I think it's ST. Now, notice how we have standard deviation for a population and standard deviation for a sample. Since it said all pitchers, I know this is the population. So this is going to be for the heights. So close my parenthesis off there, hit enter. That'll give my standard deviation. And then my mean, if I hit equals, and remember in Excel, it's actually average. So average, and then we can do the mean, and then close the parenthesis there. Now the coefficient of variation is going to be the standard deviation divided by the mean. So this is going to be the coefficient of variation of the heights, if you will. So what I can do in this box is hit equals, and I can divide the standard deviation by the mean. So that's going to be E2 divided by F2. So E2 divided by F2 should give me my coefficient of variation for the height. And remember, as a percent, you're going to be rounding it to, I think, the tenths place. It's going to be like 3.6 or 3.7%. So this looks like it's going to be 3.7%. So I need to kind of type that in. So then if I want to do the coefficient of variation for the ages, again, I can do this all in one spot if I want. So instead of doing the standard deviation mean, I just can put this all in one formula. So I can hit equals, and then I need the standard deviation. So I can type in ST population, and then I could bring this in, and that's going to calculate my standard deviation. And then I can divide that by my mean. So I can then just type in average, AVE, average. Then I can highlight these numbers here, the ages. So B2 through 13 and B2 through 13. So if I hit enter, then it should go ahead and give me my standard, my coefficient of variation for my ages. And if I go two decimal places, it's going to be 13.96 or 14.0% if I round it to a tenth of a percent. I can't really remember where they rounded on these, so I apologize for that. But we can see that from this, that there is clearly more variation with the ages than there is with the heights. So people's heights is a lot closer together than people's ages. There's a lot more variation in the ages there. So that could be some of the conclusions that we draw here. So let me see what the question says here real quick. So then compare the results. So we got those. And again, I apologize. I don't know where to round those at. I didn't bring that into this example. So pay attention to rounding still. So I'll pause there and show you how to do this also with the graphing calculator.